Gravitation Part 3 Free Fall. In the previous video, we learned about the universal law of gravitation. In this video, we will learn about free fall. Almost everything that goes up falls down. Now, in this video, let us know more about free fall. Let's start by doing a simple experiment to understand free fall. Take a ball and throw it upwards. We see that the ball goes to a certain height and then it starts falling. Here, the Earth's gravitational force is attracting the ball, and so it moves downwards. So, when an object falls towards the Earth due to the gravitational force, the object is said to be in free fall. When an object is in free fall, there is no change in its direction, but a change in the magnitude of velocity takes place due to gravity. And as we know, any change in velocity means acceleration. So, when an object is falling towards the Earth, an acceleration is involved. And the acceleration is due to the gravity of Earth. Thus, we refer to this acceleration as acceleration due to gravity. It is denoted by g. Its SI unit is the same as that of acceleration, which is meter per second square. Now, let us derive the formula for acceleration due to gravity. As we know from the second law of motion, force is equal to mass multiplied by acceleration. Let the mass of the ball in the previous activity be m, and as we learned, there is acceleration involved in a free-falling object, which is denoted by g. So, the magnitude of the gravitational force F is equal to m multiplied by g. As we learned in previous video, F is equal to gm multiplied by m upon d square. Therefore, from the previous two equations, we can write m multiplied by g is equal to gm multiplied by m upon d square, or g is equal to g multiplied by m upon d square, where m is equal to mass of the Earth, d is equal to distance between the object and the center of the Earth. Let an object be near the surface of the Earth. Then the distance d in the previous equation will be equal to r, the radius of the Earth. Therefore, for objects near the Earth's surface, g is equal to g multiplied by m upon r square. As you might know, the Earth is not a perfect sphere. The radius of the Earth increases from poles to the equator. Where do you think the value of acceleration due to gravity is more on Earth? At the poles or at the equator? The value of acceleration due to gravity, g, is more at poles than at the equator. The value of g is more or less constant on the surface of the Earth or near the Earth's surface. But for objects far from the Earth, we can calculate g using the formula g is equal to g multiplied by m upon d square. Now, let's see how we can calculate the value of g. To find out the value of g, we have to put the values of g, m and r in this equation. G is equal to g multiplied by m upon r square. Universal gravitational constant g is equal to 6.7 multiplied by 10 raised to minus 11 Newton meter square per kilogram square. Mass of the Earth m is equal to 6 multiplied by 10 raised to 24 kilograms, and radius of the Earth r is equal to 6.4 multiplied by 10 raised to 6 meters. We know G is equal to G multiplied by m upon r square. G is equal to 6.7 multiplied by 10 raised to minus 11 Newton meter square per kilogram square multiplied by 6 multiplied by 10 raised to 24 kilogram per 6.4 multiplied by 10 raised to 6 meters the whole square, which is equal to 9.8 meter per second square. Therefore, the acceleration due to gravity G is equal to 9.8 meter per second square. Now, let us perform one more activity to understand whether all objects, hollow or solid, small or big, when allowed to fall from the same height, will fall with the same rate or not. Take a sheet of paper and a small ball. Drop both the things at the same time from the first floor of a building. What do you think? Which object will reach the ground first? We notice that the ball reaches the ground first and then the paper. This happens due to the air resistance. Air resistance is because of the friction to the motion of the falling objects. Here, the air resistance offered to paper is more in comparison to the ball. However, if we perform this activity in a glass box from which all the air has been sucked out, the paper and the ball will fall at the same rate. In this video, we learned about free fall. In the next video, we will learn about mass and weight.